Hello and welcome to my shop. I'm Ron with Ideal Industries and welcome to another segment of Terminating Low Voltage Cables. Hey, in this segment we're going to talk about telephone basics, and actually it's going to be a two-part segment. This is part one. We're going to talk a little bit about telephones and what you should know before you start working on one, and give you some insights as to what you need to do when you're trying to maybe troubleshoot a telephone problem. Hey, you should understand phones have been around a long time, and if you want to make an image statement and go buy a phone from the 1970s or the 40s or the 50s, you can buy them. And these old analog phones and the early touch-tone phones are still available out there. And they normally, since most services really to all homes today are still analog in nature, they should still work just fine and should continue in the future. Now, somewhere down the road, the telephone company takes your signal and turns it into digital and sends it to, wherever across the country or where we might be trying to call. But it's, your telephone system, you got to understand, is a mix of analog and digital today. But again, most services to homes are analog in nature. Okay, so we're going to talk and get right kind of into this. And when you look at telephones today, and in the past, if I had a telephone number coming to my house, one phone line, I needed at least one pair of wires from the telephone companies to do this. So every telephone line required a pair, okay? And if I had two phone lines or three phone lines, obviously I'd need either 4 or 6 conductors or 2 or 3 pairs in order to make that happen. And in old office buildings, high-rise buildings and things like that, they could literally have hundreds, if not thousands, if not hundreds of thousands of pairs running in and out of them for all the things that are, you might find happening back in the day in old telephone systems. So today we need a pair for every phone line coming to us. Now, I'll explain this little wiring sequence a little later on, but you'll notice there's a T and an R under every one of the conductors, and you got to understand what that is. And what that basically means is it's the tip and ring polarity of the two conductors. You need to understand that basic phone is DC. Okay, and back in the day when the old neighborhood, the power went out, and our analog phones still work because they're using DC, not AC. So be aware of the fact that it is DC in nature. So what that means is positive and negative as we need in a DC circuit, okay? Now, the term tip and ring, believe it or not, comes back to way back in the day when the operator would be sitting at a console and they'd have a headset on with this pluggy thing that plugged into this console. And you gotta understand, this is back in the day when we always had to go through an operator to make a phone call. And if you remember the old movies, you'll see people cranking a handle on the side of a phone. And what that did, that generated a light on this operator switchboard over here, and they would be sitting there waiting for this thing to light up. And when it lit up, they would think, oh, someone's calling me, and so I need to, talk to this person. So they would take their little headset and the little plug-in plug into that opening, and then you could talk to the operator, and they could hook you up with the guy down the street or whoever the heck you were trying to call, or maybe long distance. So that's, I believe it or not, how that happened back in the day. Now, one of the wires that goes up the house that makes up that pair is connected to the very tip of this connector. The second conductor goes out to the home, is hooked to this what we call insulated ring, so it's a separate thing on that plug. And the sleeve in that system was their ground, so that's where the term actually came from, tip and ring. And you got to understand, this is back in the 1920s. Not many people know anything about AC or DC, and anyway, but you could teach that guy out in the field that this wire gets hooked to what we call the tip. We're really referring back to this connector, and this goes back to the ring. Okay. So that's where the term tip and ring comes from back in the day. Now, as I said earlier, this is an electrical circuit. It does have some DC and AC in it. And folks, just for pure safety reasons, if it is an electrical circuit, and you can get shocked by it, and normally not bad, but it can happen. So if you're really concerned about it, you might disconnect the service on the side of the home, and I'll show you a little bit how to do that in part 2. Before you work on your telephone services. But if you've never been shocked by phones, now, the only time you find AC associated with a phone is only when the phone's ringing, okay? And so if you strip some telephone wire and you happen to have the conductors in your hand at the time it rings, you're definitely going to get a shock out of this deal. Now, the DC here I'm not going to play with much, but the AC is kind of interesting because that does happen when the phone's ringing. And we would typically tell you your ringing voltage in a home is somewhere around 90 volts, okay? Depending how far away you might be from a central office. Now, normal AC at the outlet in your room is usually 120 volts. thereabouts, and it should be at what we call 60 hertz or 60 a frequency of 60 hertz. And that means the electrical signals here are turning on and off at 60 times in a second, which is pretty fast. And you got to understand, for old telephones, they had mechanical bells in them, and the mechanical bells had these clangers between them. And if the telephone company put a 60 hertz AC signal down that cable, that clangor would be going back and forth so many times, 60 times, in a second, that you basically would hear a solid tone. You wouldn't be able to hear the cadence in the bell. So by dropping the frequencies down, all of a sudden we can hear that cadence in the bell. And you know, when a phone rings, it's kind of a unique sound, and most people go, "Oh, that's a phone ringing." So it helped with that, and actually it makes it safer too. Believe it or not, the human body tolerates AC at 20 hertz better than it does 60 hertz, which is evidently closer to what our body actually works at. So anyway, so that's a little bit about tip and ring that you ought to know something about in the circuit, and you don't want to be flipping them back and forth, kind of thing. Okay, hook tips to tips and rings to rings is a general rule. Okay. Now, when you look at a phone, we make it into a lot of things today, other than a phone. But at its basics, what was it, or what it was intended to do? Well, its intention is to take a sound, convert it into an electrical impulse through a microphone, and then it can send it across the wire, and on the other end of the wire, in the speaker in the other phone, it will turn it back into sound. So it's really all about generating sounds. And you should be aware of the fact that the telephone company is not going to recreate everything you can hear as a human. And they don't need to. They need to be able to transmit basic good voice patterns and speech. And so they recreate basically from about 400 hertz cycle frequency sounds upwards of 3,400 cycle frequency sounds. Okay? And you should understand that all sounds are basically waves, so to speak. So it's like dropping a pebble in a pond. When I drop that pebble in a pond, I get that rippling effect, and it's going at a number of waves per foot or whatever it is. In this, it's basically creating a waves. Okay, and you can hear as low as 20 hertz. Upwards of 20,000 hertz, and that's supposedly the perfect human, and probably not many of us can actually hear that good. But anyway, so they're not recreating everything. So if you start singing on a phone, the phone company's cutting out the highs and the lows, so your buddy's never going to hear the highs or the lows of the song, and it might be one of the reasons why you might sound pretty good singing on a phone too, other than versus if you were in the room with you. So anyway, so that's all they're recreating is basic voice patterns. Okay. Now, this ringer equivalency number thing, you ought to be aware of what that is. And, I occasionally get people, ask you, "Hey, Ron, do I have an analog phone or do I have a digital phone in my hand?" Well, you can quickly tell if you look at the back of the phones should have some reference to the FCC on them. And if they don't have it, you cannot really use them here in the United States. They're afraid you're going to go out and buy a phone out of I don't know where and ship it in the United States, and it might actually damage their stuff. So if you're looking for it to say FCC and it complies with, in this case, it's Part 68 of the FCC rules. If it says Part 68 and it's asking you for an REN number, it's an analog phone. If it's a FCC Part something else, like maybe Part 15, it would then be maybe like a cordless phone, which might be more like digital. Okay, but is still going to use an analog circuit, but you got to be compliant there. Now, the REN number, I know we've all tried this, or had this happen anyway. You and I are having a conversation someday on the phone, and you tell your spouse to pick up the phone in the other bedroom, which is on the same extension of the one we're talking on. And when they pick up that phone in the other room, what happens to the level of the volume of our voice conversation? And if you're betting it goes down, it does. And the more people on different extensions, the lower it gets, and to a point where you may not be able to hear anybody. So, the question is, if I'm putting phones in somebody's home, and the guy wants 8 telephone extensions in the house, and because he's got 8 kids, and all of them want to talk to grandma at one time, can we do this? Well, this is how you figure it out. Okay. Well, all phones have this REN number associated with them, but again, it's on the back of the phone. And old analog phones had an REN number of 1. And the telephone company typically will let us have somewhere 5 or less. And if you want to know exactly what your phone company is allowing, you'll have to call them. But somewhere under 5 or less. Okay. And so the old analog phones were an REN number of 1, and you divided that into 5, which meant 5. So all 5 of us could all be talking to grandma at one time. what happens is if you go beyond this number, A, it's very hard to hear anybody on the phones because we're all on at the same time, and B, the telephone company's not sending enough energy out to your house to ring all the phones. That's the problem. Now, you know, a lot of these digital phones you buy today, they have an REN number as well, and you'll find that these digital phones are getting so low in RENs, it's like 0.2 today. So all of a sudden we could put a bunch more of those inside of a home. But if you got to a point where you were wanting to put phones in an office building and firing up literally hundreds, if not thousands of extensions, well, you need to install a telephone system for that building. It's not really residential. Okay, and the sampling rate is kind of interesting because, you know, they are going to turn it into digital somewhere in their system. And they will sample that analog line 8,000 times to actually recreate that signal for you on the other end of the cable. Okay, and when I look at how we dial out today and make a phone call, you know, that's changed quite a bit too. You know, the old rotary dial phone actually came out in 1919. It's been around a long time, and of course it's kind of dead today, but you still might find them. As I said earlier, you could find old phones on the internet. And when I look at how that old analog phone actually dialed, basically what it is we put our finger in a number on the phone someplace, which had an opening in this dialer thing. We rolled the dialer over to the stop, and we pulled our finger out of the phone. If I put it in 3, the phone would click, 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 or gave me 3 pulses, basically. And 4 would be 4 clicks, and 9 would be 9 clicks or pulses. And I'll bet you if you handed a rotary dial phone to a 6-year-old today, they may not have any idea how to use it. But anyway, so that's how that worked. And you know, the old phones, you didn't even need the dialers. You could take the handset off the phone and hit that button on top of the phone, 1, 2, 3, first number, and wait a half a second, and hit the next number and wait a half a second, and you know, and make the phone call that way too. It was very simplistic, okay, and it wasn't really reliable, okay, and so we came up with the touch tone phone some time ago. Okay. Now the touch tone phone is called a dual tone multiple frequency system, and essentially what it means is that every button on the phone is going to make a different sound. Okay. And when I push 1 on a keypad, it takes the tone over here and the tone across the top, and it merges them together, and it creates a unique sound. And when the telephone company hears this unique sound, they know you dial number 1. And that's how we identify all the different buttons on the phones. And they even have more buttons for telephone test sets and things like that. But this is typically what you're going to find on your phone in your house, okay? And again, it's a touch tone type phone system. And you know, it's interesting, I was watching a show years ago, and it was saying that the touch tone phone saved the average human almost 400 hours in dialing in their lifetime versus the old rotary dial, because it just took so much time to do that, okay? All right, so that's how we actually use the phone today. Now, I'm going to end part 1 right here, and do me a favor, watch part 2. And in part 2, I'll talk a little bit about, you know, how we wire, where we wire to, and identify the connections and stuff we're doing. So, hey, thanks for coming. Again, I'm Ron with Ideal Industries, and we'll plan on seeing you next time.